Hi, I am Lopa Mudrashen. Welcome back to my channel Electronic Science Tutorial. I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not follow my channel, please follow my channel. If you like my channel, then please like, share and subscribe my channel. So let's start our class. Welcome to the application part of Zener Diode. In previous class, we already talked about we already discussed about Zener Diode as a voltage regulator, or we can say that how Zener Diode work as a load regulator. Today, I will discuss one more application of Zener Diode, that is how Zener Diode work as a line regulator. Okay, so let's begin our class. So how Zener diode work as a line regulator, in this slide we will discuss about this topic. Okay, so we know what is regulation and why Zener diode used as a voltage regulator, because the constancy of the voltage across the Zener diode in the breakdown region makes it a useful voltage regulating device. We all know about it. Okay, and this is the circuit arrangement from which we can perform the Zener diode as a voltage regulator. And this circuit is, in previous class I already discussed about this circuit, that from this circuit we can easily calculate the percentage regulation of load regulation by using Zener diode. Today, by using this circuit, we can also design Zener diode as a line regulator. Okay, and this circuit is help us. So what is Vs? That is the input supplied voltage, and what is Rs? We all know that is Rs is the limiting resistance, and this is the Vz, that means this is the voltage across the Zener diode, and this is the Zener diode. This side is P side and this side is N side. P side is connected with the negative terminal of the power supply, and the N side is connected with the through limiting resistance. N side is connected with the positive power supply, positive terminal of the power supply, and this is the load resistance value. From here we can get the load resistance. This is the load resistance RL, and this is the IL, load current, and from here we get the regulated voltage. In previous class we get here load regulation. In today's we discuss about the line regulator. Okay, so this is the graph of line regulation. X-axis is input voltage V in and y-axis is output voltage, and this is the nature of the curve for line regulation by using Zener diode. Okay, the variation of the output load voltage with the variation of input voltage for a fixed load current is known as line regulation. That means when we change the output voltage with respect to the input voltage for a fixed load current, we get the line regulation. Okay, so here we write that the variation of the output load voltage VL, that means this voltage, with the variation of input voltage, that is the supplied voltage Vs, for fixed load current, that means this current IL, is known as line regulation. Okay, so here as a measure of regulation we may introduce the input regulation factor, that is SL, that is defined as change in output voltage divided by change in input voltage. Okay. Smaller the value of SL, better the regulation. So this is the fundamental topic of Zener diode as a line regulator. So this side is input side and this side is output side. Here we connect one voltage supply and here we connect one voltmeter. So first of all, here we connect one voltmeter, that is in this side we connect one voltmeter. This side is positive side and this side is negative side, and this voltmeter is denoted by V3. Okay, and here we connect one voltmeter. This is also another voltmeter. This side is positive side and this side is negative side, and this voltmeter is denoted by V2. Okay, and here we connect one current meter. One current meter. This side is positive side and this side is negative side. So this is milliampere. 1 milliampere current meter here we connect here. Okay. So this voltmeter, that means V3 voltmeter, is connected with the parallel of the input power supply voltage. From this voltmeter, that means V3 voltmeter, we get the input voltage value. Okay, and this V2 voltmeter is connected with the parallel connection by with the Zener diode, and from this V2 voltmeter we get the Zener diode voltage. Okay, and this is the milliammeter current meter, one current meter connected here, and this current meter the used as a load current meter. Okay, so how the practical should be done? First, to study the line regulation, set the input voltage Vs to a suitable low value. What is the range of this value? That is 1.5 Vz. If our Zener diode Vz value is 5.6, then we multiply 1.5 into 5.6 and the input is set into this value. If our Zener diode voltage is 4.7 volt, then we can multiply 1.5 into 4.7 and here we can set the input voltage Vs with this value. So this is the range. Okay. In this range, why we fixed the input voltage? Because we want the voltage across the Zener diode does not go below Vz. Right? So this condition is fixed here. Okay. Now we connect here one limiting resistance. This value we calculate in next slide. Then adjust the load current, that means this current, to a suitable fixed value. Say we fixed this value 10 milliampere by changing RL. Okay. Note the input voltage from V3 and the output voltage from V2 across the Zener diode. Okay. Now increase the input voltage in small steps and each step we note down the Vs voltage. Right? Check the constancy of the load current at each step, and if necessary adjust it to the chosen fixed value by changing RL. Right? So here we fixed the current meter by 10 milliampere or 20 milliampere. In each and every step we can check this value is fixed, and in this condition if we increase the value of input voltage, that is V3, we get the respective output voltage across the Zener diode from V2 voltmeter, and check the constancy of the load current at each step, and if necessary adjust it to the chosen fixed value, that is maybe 20 milliampere or 10 milliampere. How this may be constant or fixed? By changing the RL. Okay, so from this voltmeter V3 and V2 we get the input voltage and output voltage, and V3 is plot into the x-axis and V2 is plot into the y-axis, and the nature of the graph is here. So this is the practical procedure of Zener diode as a line regulation, and from this graph we can easily measure the line regulation percentage. Okay, so this is the procedure: change in output voltage divided by change in input voltage. If the value of SL is smaller, better the regulation. So this is the overall performance of Zener diode as a line regulator. Okay. In this slide we calculate the limiting resistance Rs value. Here we consider one Zener diode, that is 5.6 volt Zener diode, which power is 1/4 watt and Vi max is 10 volt. So we all know that is power equal to voltage into current. So from this relation we can easily get the value of IZM, that is the power divided by voltage, and here we get 44 milliampere. Here we consider 5.6 volt Zener diode voltage. If you consider 4.6 volt 4.7 volt Zener diode voltage, then you can divide the power by 4.7 volt, and here we get your result. Okay, so this is the IZM value. Then we can calculate the RS value, that is the Vi max minus Vz divided by power into Vz. From this we get, that is 10 minus 5.6 divided by 1/4 into 5.6 ohm, and here we get 100 ohm. If we consider here 4.7 volt, then this value may be changed. Okay, so this is the procedure of calculating the limiting resistance Rs value. Okay, so in this way we can easily calculate the value of Rs resistance, which is used in the line regulator circuit arrangement. Okay, I hope you understand this topic. Thank you, friends. Thank you. With this we have come to the end of our session. I hope you like this video. If you like my channel, please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.